Well, welcome to this slightly unusual session in the sense that we have two blocks. And instead of doing one session on .NET and one on Java, last time in Amsterdam we figured it would be nice to do one combined session on both. One API inspiring the other and vice versa. I've been working with this guy here for some years, so it was all selfish when I thought of combining this so I could finally see what he's been doing. And so we're doing two sessions. So that is this 40 minutes, then we have a break, and then we do another session. And probably this first session will mostly be talking, and then the second session there will be a little more questions and showing how it's done in code. Okay, excellent. Well, first off, so welcome to validation in .NET and Java. My name is Ewout Kramer, and I work for a company called FHIR, based in the Netherlands in Amsterdam, just a 7 hours flight from here. And I'm a software engineer by profession. I loved writing compilers and operating systems, and I got lost in healthcare. And a member of the FHIR core team, and I work on the .NET API, and I created most of the stuff that we'll be talking about today, which is the validation API. And next to me, this gentleman.
Cool. So I'm James Agnew. I am the lead for the HAPI project, which of course is the reference implementation in Java for HL7 FHIR. Among other things, I am the CTO with Smile CDR, and also work part of my time at University Health Network, which is the sponsoring organization for the HAPI project.
All right. So I was starting to look at what's happening there. I should be looking here. I guess what's true for both of our engines is that we're talking about validation here. So if we're doing validation, what are our ingredients? What are our inputs? Well, of course, I'm assuming there is a bit of instance data that you want to validate. So when you're calling any of the validators, there needs to be instance data flowing into the validator. And you want to validate that instance against a structure definition. That's how it works in FHIR. I mean, you could validate it against XSDs, you could validate XML files against XSDs, and so on. But what we're talking about here mostly is about validating the very FHIR-specific validation of validating a FHIR instance against a structure definition. So you've been busy drawing up your structure definition, writing your FHIR path statements and whatever, and now you want to execute that whole thing against an instance, and that's what our validators allow you to do. I think your validator in mine also allow you to do just XSD validation, but that's no fun. We can all do that. Running validation against profiles or structure definitions is what we want to talk about. So ingredient number 2 is the structure definition that you want to validate that instance against. By the way, that could be a structure definition straight from the core specification if you just want to validate your instance, for example, against a normal patient as specified in the spec. Pretty soon, that structure definition will reference terminology. So saying, well, patient.gender should really be a code taken from this value set. So the third ingredient is a stream of value sets, and most likely a terminology service that allows you to validate a code against a value set. And then finally, those structure definitions will contain bunches of FHIR path constraints, so you need to somehow run those FHIR path constraints against the instance data as well. And then if you combine it all, put it in a mixer, validate, you probably want some outcomes. And that's basically validation, and that's what our engines do. So let's start with the one in .NET, showing you how that's done in .NET. My first slide, more or less, is the packages. So if you want to download the .NET library, these are the packages available on NuGet. And in the middle, we have the central one, HL7.FHIR.core, which has the model classes, serialization, HTTP client. If you followed the beginner's tutorial this morning, you've been talking mostly about HL7.FHIR.core because that's where all the classes, the POCO classes are, patient, observation, and so on. The basic way to get in them into and out of XML and JSON and HTTP client. All the other libraries support libraries, but like HL7.FHIR.specification contains what you need, access to the definition, so access to the structure definition that are in the core spec, terminology service and validation. So that red box there, that's the main one you want to download. Actually, if you download that one from NuGet, you'll get all the other ones because they reference the core stuff and the support libraries and the FHIR library. So here, this FHIR library, by the way, is all usable by itself if you wanted to just run FHIR statements on any kind of instance. So if you've been following my FHIR presentation like to this afternoon, if you download this in .NET, you could run FHIR along with this. But obviously, the validator needs FHIR to do validation too. So this is the set of libraries that you'll be downloading into your project. Good. So I started out saying what are the main ingredients of validation. The one is instance data. You need some way to get to the data, point to the data and say, here, validate this. In the .NET API, I decided not to write the validator against just the POCOs. So of course you can say, here is a patient class, an instance of a patient class, and validate it. But I abstracted it away a little bit under an interface called IElementNavigator. And if you looked at my tutorial this afternoon, you saw that all the data is represented independent of format. So whether you're dealing with JSON or XML or RDF, IElementNavigator is a class in the FHIR.NET API that has an abstract representation of FHIR data, independent of the format. So by writing the validator against that interface, I was sure that I was not, either limiting to myself to just validating XML or JSON. It can actually validate anything that implements that interface, including maybe your own custom object model, which is an interesting thought by itself. You could even run the validator on your own object model as long as you can implement the IElementNavigator interface. The FHIR engine is running against that interface as well, so you could run FHIR against your objects as long as you can map it to IElementNavigator. I provided 3 implementations in the library, one called XML DOM FHIR Navigator and JSON DOM FHIR Navigator, which are implementations straight on an XML and a JSON file. But I'll be reviewing these heavily. I am actually at this moment. So this summer we'll have a new set of these with even better performance. And there's the POCO Navigator, which implements this interface on top of a normal POCO. So I think the interesting thing is that for me, stuff stored in in-memory classes in POCOs is just one of the formats that I'm supporting next to JSON and XML or your own formats. And then, of course, once I've done that, then the FHIR validator just uses this interface, just like the FHIR interpreter to does its magic. So that's how instance data gets into the validator by parsing it through one of these concrete implementations of IElementNavigator. Any questions so far? It's a pretty basic fact to understand, otherwise you'll get lost in the rest. So that was ingredient 1. Ingredient 2 is, okay, so I'm validating this against what exactly? And most of the time you're validating it against a structure definition. So you need a way to get to a structure definition. Now, the .NET API packages the base HL7 specification in the NuGet HL7.specification.stu3 or DSTU2 or R4. Well, the R4 one is not ready yet. And it has a file, a zip, specification.zip, with basically all the definitional data of the FHIR specification. So that allows you to validate an instance against the FHIR specification, not yet against your own profiles or your own stuff, but at least against the base FHIR spec. Now, it would be nice, of course, if you could extend that a little bit and include definitions coming from other sources. So the usual thing to do as a developer is say, well, let's abstract that behind an interface, and in the .NET API, that's called IResourceResolver. And it resolves, given a canonical URI, it resolves to any resource. So a canonical URI probably deserves a little bit of explanation, but that's the identifying URL most of the time, where you could either find a structure definition or a profile on the web, or at least it's unique across your system. So given that URL, you should be able to locate the physical spec. So say http FHIR or http hl7.org/FHIR/structure definition/patient, for example. If you call resolve by canonical URI with that string, would return a structure definition that has the definition for patient. That's the canonical URL for patient. And if your structure definition is referring to other structure definitions, it always does so by canonical URL. So it makes total sense to have an interface that, given a canonical URL, resolves somehow, I'm not saying how, this is an abstract interface, somehow to a structure definition. So I provided a few concrete implementations. An obvious one is the zip source, which takes that specification.zip that I just talked about, indexes it in memory, and allows you to quickly find your canonical URL inside a zip. But I have an implementation called directory source, which does that for a directory of files. So that's running next to your executable or inside your web server or whatever. There is one called web source, which would actually try to resolve the canonical URL to a web address. I don't know whether I would recommend it in any kind of running system. And there's two special ones, a cache resolver that will make sure that once you have retrieved one of the resources by canonical URL, the next time it's cached in memory. So that just calls any other existing implementation and caches whatever the result was, so you don't have to get out to one of these more expensive sources here. And then there's a multi-resolver, and you give them a list of implementations of that interface. We'll try the first one. If it finds the resource, fine. We'll try the second one, and so on, and so on, and so on. So with this, you could build your own implementations. Maybe you compile it inside your executable, or you have a database. And if you implement this interface on a database, you could store your structure definitions inside your own database. And then the validator would be able to get to these structure definitions, whether they're stored on disk, inside your database, or wherever they are. Any questions about that? Third ingredient, terminology. So we have currently a pretty simple interface. Again, it's an interface, ITerminology that mimics the terminology service described in the FHIR specification. So inside the FHIR spec, and I think Rob is talking about that tomorrow, there's a whole set of functions for working with value sets and code systems. And the interface that I defined in the .NET API just mimics that definition. It's not a REST, it's not a REST interface, but it's a .NET ITerminology service interface. And I wrote a few implementations again against those. One is called local terminology service. It's a pretty simple in-memory terminology service that, given a value set and a code, at least can tell you whether that code is in the value set. It does some limited expansion. It does a little bit limited lookups, but it works for many of the simpler value sets. Of course, if you have a decent, real terminology service, you'd like the validator to not use any, maybe use the local terminology service, but if that fails or the value set is too complex, you want to go out to your production terminology service and call that using the FHIR interface and validate codes against value sets and so on. And there's an implementation called fallback terminology service, and you could almost guess what it does. It first tries the local terminology service in memory, and if that reports that this value set is actually too complex or it doesn't know about it, allows you to fall back and then call to an external terminology service. And again, you could implement this maybe on this interface as well on an existing service that does not implement a FHIR terminology service interface. The validator doesn't care. All it cares is that you implement this ITerminology service interface, and then it has all it needs. So those are the ingredients, and which then finally we can compose into the full meal, the main course, which is running the validator. So one of the inputs to the validator is the IElementNavigator. So that represents the FHIR data, FHIR POCOs, FHIR XML, FHIR JSON. IElementNavigator represents that data. That goes into the validator. As soon as the validator starts validating that, it will encounter canonical URLs, either because you pass it to the validator saying, I want you to validate this instance data against this structure definition, or because the structure definition, you're validating it against references other structure definitions, or actually if it encounters extensions, because FHIR instances can, of course, reference extensions, and these point to structure definitions as well. It will go out to the resource resolver and try to find it. As I said, one of the things you probably have installed most of the time is the base FHIR definition, so at least the validator can validate against the base spec. It will, of course, encounter terminology queries in the structure definition. There are bindings in the structure definition for it needs a terminology service, and it calls out to the interface back there. And there's actually kind of a loop, because while resolving terminology, you will encounter references to value sets, which then again asks the resolver to resolve all that stuff. And finally, when the validator is doing his work and is done, it reports the results in an operation outcome, which you could then return on your FHIR server. So these are the names of all the classes and interfaces that are part of the specification library, and which you basically use to run the validator in a server or in a desktop application, or maybe even on your phone. The practicalities around that are all that stuff in the HL7.FHIR.validation namespace in the specification assembly. You new up a validator, passing it settings, and the settings point to the resource resolver to use, the terminology service to use, and so on. And then you validate it. Once it's configured, you actually call validate either on an XML reader, on a POCO, or on IElementNavigator, is that abstracted interface, and the result is an operation outcome. In code, it looks like this. So I'm constructing, in this case, so let's start with the source of the structure definition. As you can see here, I created a directory source, which means that if you installed some of your structure definitions in C data my profiles, it will find that. And I created zip source.create validation source. This creates a source for the standard FHIR specification.zip file. And I combined these two into a multi-resolver, which means that if you ask this multi-resolver to resolve a canonical URL, it will first go out and look inside your directory here. And if it doesn't find it, it goes out into the basic FHIR specification. So like this, it would know all the basic FHIR classes. And in addition, it would know all your profiles that you have added to your application. And because going out to a directory and a file system and zipping stuff is costly, I wrap that whole stuff inside a cached resolver. So once I've got a patient structure definition, it won't fetch it a second time. Here's some validation settings. So I'm basically saying, well, I've just resource resolver. This, it should actually be source here. This is the resolver I just created. Enable XSD validation. Yeah, why not? Let's do XSD validation as well on top of this. I don't want trace information. Really, that's a lot of. And do resolve external references. So if you have an instance that refers to another instance, the validator will go on validating the instance that the resource reference is pointing at. I'm newing up a validator with these settings, and then I'm actually running it over here. Validate.validate, if not success, ouch, do something. And here you can see another call where I say validate this instance data, my patient, not against the core definition, but against this profile, which then hopefully is installed inside this directory. Some caveats here. You can read them at home, but the validator is never ready. I'm still not doing some of the slicing features, but I'm still hoping this summer I'll have some time to get that finished. And yeah, loop detection is another one. Resources referring to each other would currently cause a problem. There's a way to play with the validator. One, because there's a Windows executable that I created on GitHub. that was just to demo that the library worked, but it's kind of fancy currently. It's really usable to just paste in your data and run it against all kinds of structure definitions. Of course, you can repeat the code that it showed and calling it validator in code. And you can actually, it's built into simplifier.net as well. So there is simplifier.net/validate. And that is a very quick way to run the validator on the web, because all you have to do is paste in an instance and press the validate button, and you'll be running this validator. Okay. That's the .NET part. Questions? I think it depends on the context that you're running it in. Validation is generally pretty expensive. So for our validations, our server, Vonk server, hasn't enabled that by default to doing it all the time. You really have to, enable it, because it's an expensive operation. I can imagine that in controlled situations you enable it while testing, but once you know that both systems are actually communicating fine after some time, you can disable it because you're wasting cycles. But if you're getting external data and you want to make sure that it's valid, you could have some kind of well, it's not a firewall, but you could have like a queue of data that you validate before you actually import it. But it's a heavy operation, because you go out to terminology services and structure definitions. So it's a pretty heavy thing. Any other questions? All right.
There we go. Cool. So, I had a screen for a second. Hopefully this will come back. I'll deal with the fact that it's not up. Oh.
Something's happening, don't worry.
We had it for a minute. Well, that's something.
Yeah. Sure, we can.
Oh yeah, absolutely.
That might be it.
Not a bad idea.
You know what? Is this a resolution issue, maybe?
It could be. It was working this morning on the other room.
It's trying to get to grips with your resolution.
Yeah, really. Well, you know what? Let's just plug it into yours then.
Do you have the content?
Yeah, he's got similar content. So
So this is, and then it switched off like last time.
yeah.
No,
Let's plug it into yours then, just to save.
I would
That's easier. Cool. Well, so while he's setting that up, I mean, the fun thing is, Ewout started by talking about what is validation and how does it work and all of that. The thing that I sort of like to start with, and I mean, it works well because it's exactly kind of the question we just had, sort of what should I be validating and in what context do I do it? I think that whole sort of subject is a really interesting one, actually. I mean, ultimately, there is really not a right answer to what should you be validating and when should you be running the. Oh, thank you. When should you be running the validator? Ultimately, I mean, as Ewout was saying, no matter what you do, validation is always an expensive operation. Certainly, every code that's being looked up where you're going out to a terminology service, every parse of a FHIR path expression, all of that stuff, it all adds up, of course. And the net result is, basically that every validation is going to add an incremental sort of cost to the amount of time that it takes to process whatever it is you're doing. The other consideration, of course, is what do you do when validation fails? Certainly, there are situations where you might want a production server to reject every last bit of data that isn't fully valid when it comes in. There's also lots of circumstances where that would be a terrible idea because, losing data is much worse than capturing data that might not be fully valid. So, I mean, this is one of those things where there's really not a great answer to what should you be validating, only sort of general principles to follow. For what it's worth, most of the systems I've ever been involved in developing, we've always sort of tried to stick to a principle that in development, we crank all of the knobs up to 11. So we will have validation be as strict as it possibly can. We will reject data that has even the slightest issues on it. You know, we'll be validating every last code. We'll be strict about all of that. And then when we move to production, we'll be a lot more lenient. So maybe we tag stuff that's not valid. Maybe we do structural validation, but not semantic validation. So I mean, these are considerations and things to think about as you sort of decide where do we do validation. I guess the other consideration is, do you validate on the way into your system and the way out, or one or the other? If you're building a server, certainly there's arguments for validating stuff on the way in, but not validating again as it leaves the system because it's been validated once. But there's lots of approaches to be taken there. So this is all stuff to think about anyhow. Within FHIR, I mean, the fun thing is, if you look at the big picture slide that Ewout was showing, I mean, I guess there's not that much room for interpretation in the FHIR spec as far as how validation works, but every last one of those boxes has an equivalent in the Java world. The class names are a little bit different, of course, but validation, I mean, basically everything I'm about to say is a repeat of what Ewout just said, but with slightly different words because it's in Java this time. And I'm Canadian, of course, so we both have funny accents up here. There are, I guess, one big difference. So HAPI's actually got two models of validators. I assume there's probably something like this in the .NET API as well. But we've got this other concept called the parser error handler. And the parser error handler is intended as a purely structural validator that's sort of applied to the parser as it parses. It doesn't do any sort of rich inspection of the content. It's certainly not validating codes or anything fancy like that. But it is sort of detecting any elements that are in your payload that aren't actually a part of the underlying resource profile. It does basic checks on cardinalities. It looks at data types, so it would flag, for instance, a time zone being missing on a date time, or a decimal number that's got a letter in it or something like that. So parser error handler it's got the really nice property that it's blazing fast. There is no performance penalty to be paid by using a parser error handler, and it sort of gives you a quick way of either rejecting content that's just plain syntactically incorrect, or at least logging an error when something like that comes in. I'm not going to say much more about the parser error handler because it's a real it's a poor man version of validation, but I mean, it's a tool that every system I use, even if I'm not doing any other validation, I'll spend a bit of time thinking about parser error handling and how strict I want to be there. Validator, on the other hand, I guess I had a slide about that. Validator, on the other hand, is, I even had some examples. I'd taken those out. I'm all thrown off by this not being the right content anymore. This is how it works anyhow. So the way this works, of course, is you basically, on your parser, there's a method, set parser error handler. There are a few implementations of this interface, IParser error handler, one of which is the lenient error handler. All that does is log any problems, or optionally just ignore problems silently. There's another one called strict error handler, which will basically throw an exception, return back an HTTP 400 to the client as it comes in. And it's also, of course, an interface. So if you wanted your own custom handling of errors, you've got that option as well.
Yeah.
Right.
Well, so this is, I didn't have that one in the .NET API, but I'm building that as we speak. As I was sitting in the plane, basically, I was doing this.
Right. There you go.
It's a really good idea.
Yeah. Well, I would say it's probably the most important kind of validation for production systems, just because it's fast and there's no penalty to be paid by that type of thing. So the other kind of validation, so in HAPI we call this profile validation, and this is exactly the stuff that Ewout was just talking about with the .NET validator, is the idea that we validate based on profiles, whatever form that takes. Profiles in FHIR can be structure definitions. They certainly can be XSDs, because all of the profiles, like all of the resource definitions in the FHIR spec, are distributed both as structure definitions as well as schema and schematron files. And any of those are options. Profile validation goes a whole lot deeper than the parser error handler, though. Every code will be looked up in a terminology service. Things like data types and extensions can potentially be validated. So it's a lot more thorough, and there's a lot of options there. The way this works in FHIR is you've got this module called the validator, and then you've got essentially a set of inputs, and this kind of, this is our way of calling that IResourceNavigator. We basically sort of internalize that, so it's not exposed out as an interface, but again, we will take in sort of POJOs as an input, which is, of course, the HAPI data model classes, or you can send in raw JSON, or you can send in raw XML. Internally to the API, it will do validation, and I'll talk about how that works in a second. Your outputs that come out of the thing are a simple Boolean pass-fail, which is essentially were there any errors detected, a list of any issues, and the issues, you just get a list back with a little structure that gives you, the line number where the problem was, the severity, a message, information about the profile that tagged it if that's applicable, and then of course an operation outcome resource which you can use to return to a client if you're building a server that's doing validation. The HAPI validator is built on this notion that you can sort of plug modules into it. And we provide a bunch of different implementations of those modules. There's really, these days, people are almost always using the same one. The default in the system remains Schema and Schematron, just because those two are really fast. So there is an implementation called the Schema Validator module. There's a second one called the Schematron Validator module. And most people, if they don't change any settings, will just use those two in concert. And then we've got these other ones called the Instance Validator module that is looking at structure definitions and doing a much richer set of validation. The Schematron and the Schema and Schematron are complete. They're quite good, just in the sense that they will validate your entire payload. They look at all your element names, all your data types, all of that stuff. They validate all of that. They have one big sort of drawback, which is that the output they give you is a little bit hard to comprehend. One of the challenges with XSDs in general is that they typically, if you've got a missing element, for instance, they don't tell you that that element is missing. They'll give you the name of the next element that they found there, and you'll spend a while staring at the output and wondering what it's trying to tell you. Not great, but it does work. Using the Schema Validator, it's fairly simple. I've got an example up on the screen. As I was saying in the HAPI intro tutorial this morning, the gateway into HAPI always is this thing, the FHIR context object. Just like with every other part of the library, you create a FHIR context object. In this case, you ask it for a validator. Typically, and I'll show you in a minute, you would be adding some modules to the validator. But if you haven't done that, you're using the default, which is Schema and Schematron. You would pass in whatever your input is, and that can be a string with JSON or XML content, or it can be sort of Java classes that are proper POJOs. And your output is this thing called a validation result, which has that pass-fail, your issues, and your operation outcome. So in this case, I'm passing in this example, I'm creating an encounter. As you can see, I don't have a status associated with the encounter, and status, I will tell you, is a required field on the encounter resource. So this is something I will expect to fail, and sure enough, this is the response I get back. And as you can see, we get this somewhat baffling CVC complex type 24B. The content of encounter is not complete, which, ultimately you can kind of figure out what it's getting at, but it's a nice example of the unpleasantness of schema validations. You'll see the equivalent on the profile validator in a second. What happened there? That's fun. So the same thing. I think what I'm trying to point out here is that it works the exact same way with XML encounters as well. So profile validation, this, thank you. We already covered this. So profiles in FHIR, of course, are structure definitions, value sets, and code systems. Resources have a little spot in their metadata, which is the little block up at the top right underneath the ID, where they can optionally declare that they conform to a given profile. The instance validator will look at that. It will validate against base profiles. So if it sees a patient resource, it will validate against the base definition of what a patient resource looks like. That's the stuff that comes out of the FHIR spec. And it will validate against any declarations of explicit profiles that have been provided in the metadata section. Much like Ewout was talking about in .NET, we've got sort of a pluggable API for where the validator can go out and get the things it needs. One key difference between the Java API and the .NET API, we don't split out the concept of fetching the resources it needs, structure definitions and the like, from the concept of the terminology services. Looking back, I mean, probably if we were doing it again, we might split those, but functionally it ends up being the same thing. We've got a single interface that sort of does those two functions.
If you write an API, you're never gonna look back and change anymore, right?
Yeah.
That's the thing. Yeah.
Exactly.
I never realized that when I started doing this. You've been doing this with HL7 V2, so you knew, but I was like, gosh, I want to make up my mind and change it.
Yeah, no kidding. Ultimately, we've got, so all of the things that are up here, we've got a bunch of implementations of this iValidation support. You can create your own, of course. We provide a few. There is one called the default profile validation support, and that just uses the FHIR built-in definitions. So that's the built-in value sets and code systems and structure definitions that are a part of the FHIR core specification. There's this thing called pre-populated validation support, which is actually just a glorified set of hash maps. So you can load it up with your own profiles and structure definitions and that type of thing. There's this thing called the validation support chain, which is used to chain a bunch of validation engines together. Finally, JPA validation support, which is a module that sort of goes into HAPI's server module and will actually look in your database for anything you've uploaded into the database. There's one more that I had on my own slides that I will circulate a link afterwards because it was the most interesting one. And that's the brand new IGPAC validator, which will actually take an IGPAC file, an implementation guide pack file, parse the zip file, and then apply all of it. That, and I think to this room specifically, could be quite interesting, just because if you are implementing the Argonaut profiles, which of course is a common thing to be doing, there is an Argonaut profile IGPAC, and it's literally 3 lines of code to sort of have that loaded up and then brought into your validator so that you can validate against Argonaut profiles, which is kind of a neat thing. I will circulate links on how to do that afterwards. Questionnaires, I should mention, the validator does handle questionnaires. So if you've got in your system a questionnaire resource and then you try and validate a questionnaire response resource, the questionnaire will be fetched, and things like mandatory answers, data types of answers, that type of thing do get validated just the same way as structure definitions are applied. So that's kind of a useful feature for anyone working with questionnaires. This is a code sample for how it works, and really the only important part. It works roughly the exact same as the previous example, except that this time the key line is underneath where I say create the validator about 2/3 of the way down. We're registering a module into the validator, and this is this FHIR instance validator. And in this case, I'm just providing it with the default profile validation support, but that could be any of the chains I talked about before for fetching up validation support. This time with that same example, we get a response back that is much more sensible to human beings. So this time we see profile, and we've got the name of the profile, element encounter.status, minimum required equals 1, but only found 0. So unlike with the XSDs, humans can look at that and say, oh, I get what that's talking about, which is nice. So profile validation is a lot better from that perspective. I think that's that.